everyone and welcome back. Today I am going to be telling you what is OpenCV and the methods of it. This is actually a pretty easy and fun concept. Introduction. OpenCV is an open source computer vision and machine learning software library. OpenCV was built to provide a common infrastructure, means a template, for computer vision application and to accelerate the use of machine learning in commercial projects. This library has more than 2,500 optimized algorithms. These algorithms can be used for detecting and recognizing faces, identifying objects, classifying human actions in the videos, tracking moving objects, removing red eyes from images taken using a flash, stitch images together, producing a high resolution image of an entire scene. The library is used extensively in companies, research groups, and governmental bodies. Activity of the day. Here are some methods that we can use by editing an image using Python. The basic techniques involve reading an image, writing image, getting basic information, image rotation, image transpose, cropping an image, blurring an image pyramid, and edge detection. So let's move on to the coding part. Before starting the coding part, I'm going to be telling you how to upload an image in Google Collaboratory. First of all, you choose this folder right over here. Then you click on upload a file right over here. So once you go, you click on this and you are done. You click on OK and you have your picture. And this is your picture. So now we are going to move on to the code. Now, number one thing is that we are going to read the image. And for reading the image, we are going to have a specific code. So first of all, from Google Collab.patches, import CV2 underscore I'm show. We're going to import CV2. Then we're going to save the image in a variable called img. And we're going to put a bracket. And your image over here in the folder section, you're going to click on the three dots, click on copy path, and paste it right over here. Then we're going to go to the next line, which is cv2 underscore I'm show img. Means that is going to print our image, as you can see over here. And after you're done printing the image, we are going to move on to another code, which is called getting the information. So what we are going to do, we are going to write the shape, and in write, which means that we are going to write it over here. So that copy path you have, you're going to again copy the path over here and paste it. So in write, the picture you have and we have img. Then we're going to have img.shape. So we're going to print img shape 0 and img shape 1. Click on run, and this is our here. So we have 1308 and 736. So now, as you can see over here, we have the start column, the height, and we have the width, and we have also our picture over here. In the end, we are going to have imshow.img. So we're going to run it right over here, and as you can see, we have our cropped image. It's a little bit cropped over here, as you can see. And now we are going to move on to the next part of the coding. And the next part is rotating the image. So what we're going to do, we are going to rotate the image. It's very simple and it's very easy as well. So we have our height and we have our width, and make sure for the image you shouldn't be having the wrong file. So we have this rotation matrix, we have the get rotation matrix 2D, the width and the height, and we have 3401. And then we also have this rotated image, the warp outline. And these, you can say that these all codes help in rotating the image. So we're going to go ahead and run that. And as you can see, our image just got rotated. How can you tell if it got rotated? Right over here. You can see here it's rotated, clearly visible. And the below image right over here is the original one. We're going to move on to the next part of the code. And the next part of the code is blurring the image. So we're going to import few specific libraries. just like these. So we're going to import from Google Colab Patches, import CV2 underscore I'm show. We're going to import CV2, then we have NumPy and our picture. So what we're going to do, we're going to copy the path right over here and we are going to paste it right over here. Then what we have our kernel NP array, then we have kernel by 25. And now we're going to print our kernel. And then we have this blurred, we have filter -1 kernel and I am show that blurred. This is also the blurred version as you can see. So we're gonna move up, everything is totally clear over here. But when you move down, it's slightly blurred just over here. See? Now we're going to move on to the next part of the coding, which is making big images, making images bigger. So what we are going to do, we have this imread and we're gonna have smaller than larger. So I'm going to be changing the path of, make sure you copy and paste the correct path. After that we have CV2 pire down. So you can say that these code is for creating the image larger and making it smaller as well. So when you run it, as you can see, we have a smaller and a larger image. Right over here we have this one, but if you have move up we have this one, then we have this larger one which is quite large, and then right here at the bottom we have the small one. So you can say we have an original one, then we have a zoomed in version, and then we have the miniature version. After that we have to make, yes, we have to detect the images, and detecting the images we will be using Canny. Canny is also a function and it is a pretty easy one. So we're going to click it here, and so what we're going to do, we have Canny and capital C Canny, we have 7 and 200. After that we're going to imd.show. So what this is going to do, this is going to detect the edges of the images. As you can see right over here, this is the moon, there were the stars, this is the lake, and these are the flowers right over here. And that was the last of our methods. I hope you guys enjoyed it, and please subscribe to my channel for more videos.